functions, we're just going to pick up where we left off yesterday. So yes, I know you guys have already seen this, but what I'm going to do is just pick up where we left off yesterday. So just really quickly, we talked about what a function was. We talked a little bit about domains and ranges, how you can map things from the domain onto the range. Remember, the domain are our input values, also called our x's, and the range is our outputs, also called our y's. And we can write things as ordered pairs. Notice in this case right here, the ordered pairs are 2, 4, 3, 9, 4, 16, and 5, 25. If 2, say 2, 5 was listed here as an ordered pair, then this would what?
Not be a function.
It would not be a function because we have the same x values that would have different y values, a y value of 4 and a y value of 5, making it not a function. Anna, can you grab my door, please? Thank you. All right, we talked about, there's a helpful box on page 16 if you need to look at that for reference. You certainly may. And then we started talking about what do you do with functions, and we talked about replacing the x value with whatever the x value is, and then computing what the answer would be. So moving along, and this is where you guys need to start writing again. We're going to start talking about piecewise functions, piecewise functions. So wherever we left off, wherever you left off in your notebook, pick up from there, please. A piecewise function just means that you have 2 or more equations over a specified domain. And I like to think of piecewise functions as functions that are broken into pieces, just as this one is right here. It's telling you that the function in this case has 2 parts, one of them being x squared plus 1, the other one being x minus 1. So how do you know what to use when? Well, it tells you specifically right next to the function rule, tells you specifically when to use it. So you're going to use x squared plus 1 when the x value that you are given is less than 0. And then you're going to use x minus 1 if the x value that you're talking about is greater than or equal to 0. Piecewise function made up of 2 pieces. So if I ask you to evaluate this function, this piecewise function, when x is equal to -2, which of the 2 equations are you going to use? Are you going to use the top one, x squared plus 1, or are you going to use the bottom one, x minus 1? If the x value is -2, which one are you going to use? Yes? Go ahead, Michael. The top one, yes. You're going to use the top one because this x value, -2, is less than 0. It's less than 0, so that means that when you compute this, you have to use x squared plus 1. So what I did here was wrote f of -2. F of -2 is equal to -2 square it plus 1. -2 squared is 4. Add 1 to it, you get 5. So your answer is 5. But I'm also asking you guys to evaluate it when x is equal to 1. When x is equal to 1. Well, if x is 1, 1 is a number that is greater than or equal to 0. So if it's greater than or equal to 0, you're going to use the bottom function, which just says you take the x value and you subtract 1 from it. So the x value is 1. So I'm going to do 1 minus 1, giving me 0. Questions? Does that make sense? You just need to be paying careful attention to the notation. The domain. A domain is the set of all real numbers within the expression, which the expression is defined. We've talked about domains many times in the past. Last year when you guys were in Algebra 2, and then again the year before when you were taking geometry. So I gave you an example of this. F of x is equal to 1 over x squared minus 25. 1 over x squared minus 25. It's a fraction, would you agree? And in a fraction, the denominator can never be
0.
Thank you. Can never be 0. The denominator cannot be 0. So I wrote over here, big arrow here, denominator cannot be 0. So in a situation like this, you could put anything in for x. You could put fractions, you could put decimals, you could put rational, irrational, positive, negative. You could put anything in for the value of x, except there's a number that wouldn't work because it would make the bottom of this fraction equal to 0. So what is it going to be? It's going to be 5. If you put a 5 in there, you're going to get a 0 on the bottom. So if x is equal to 5 or x is equal to negative 5, that means that x squared minus 25 would be equal to 0. So x cannot be, notice the use of my equal sign with a line through it, that means it cannot be positive or it cannot be negative 5. So let me talk to you for a minute about how I came up with that. Some of you can look at x squared minus 25 and know immediately that if you put a 5 or a negative 5 in for x, you're going to get a 0 on the denominator. But let's say it didn't come to you that quickly. What you're going to need to do is x squared minus 25 is equal to 0. And then you're going to have to solve for x. Put it equal to 0 because we know that that's the value that we do not want this equal to. So to do that, you add 25 to each side, leaving you with x squared is equal to, now those two have canceled out, 0 plus 25 is 25. You take the square root of each side, and x is equal to, what is the square root of 25? It's 5. But not only is it 5, but it is positive and negative 5. So we know that if we replace x with a positive or a negative 5, it's not going to work. So you could tell me certainly that x cannot be positive or negative 5. You can write your answer just like this. But another way to write that in what we call interval notation is to write it like this. Notice the use of my parenthesis. Any answer will work from negative infinity all the way up to a negative 5. Can it be negative 5 though? It cannot actually be negative 5, so I have a parenthesis here. The parenthesis meaning it doesn't include the negative 5. What does this U mean? Do you guys remember that from last year? Or. It means or. It can be anything from a positive 5 all the way to infinity. Now I'm second guessing this. That's not right.
I thought there was a bracket.
There's a bracket where?
I thought, like, if it didn't include the number, then it was a bracket. So.
If it didn't include it, then it's a parenthesis. If it does include it, it's a bracket. Yep. You know what, you guys, and as you gotta add this to your notes. I'm just realizing as we're talking about this right now that there's an error here. Because this is saying that it goes from negative infinity to negative 5. And then there's a big old hole until you get to 5. And that's not true. What's wrong with my reasoning here?
Numbers in between.
Yeah, the numbers in between. What about the numbers in between negative 5 and 5? Those are included also. The only numbers it can't be are exactly negative 5 and exactly 5. So what I need to do here is add something. Anybody want to take a guess at what I'm going to add? Another U. Yes, another U. So right in between here, I'm going to put a U. It doesn't include negative 5. I'm going to put a parenthesis there. Negative 5. It goes all the way to what? 5. Very nice. Finish your parenthesis there. There's a break at 5. So I'm going to put in, well, here's my other U right here. The other U is already there. an interval notation, because you might see this in your book, or like you check the back of the book might have it written like this. So I just want you to be comfortable with that, okay? All right, another example. F of x is equal to the square root of x. What can you not take the square root of? You cannot take the square root of negative numbers. So the domain in this case is that x can be anything except it could not be any negative numbers. X cannot be negative. So we say that the domain is, now, can it be 0? Can you take the square root of 0?
Yeah.
Square root of 0 is 0. So notice my use of the bracket here. You guys were asking about that a few minutes ago. Here's your bracket. So it does include 0. It goes all the way to positive infinity, and then infinity, of course, always gets your parenthesis, not a bracket. The range, the set of all real numbers assumed by the dependent variable. In other words, the range is the y values. What are you going to get out of the function if you put in a bunch of different inputs? And an example of that, f of x is equal to the square root of x. We just talked about that above. We knew that the only thing that you could put in for the x's are zeros or positive numbers. Agreed?
Yep.
Zeros are positive numbers. So when you do that, what kind of numbers are you always going to get out of it? Could you get 0 out of it? Could you get 0 as an answer? If you took the square root of some number, could you ever get 0 as an answer?
No.
Yeah, what if you took the square root of 0? You took the square root of 0, you would get 0, right? So we could get an answer of 0. What kind of numbers are we never going to get out of it? We're never going to get negatives. We could get 0. We could get anything above 0. So in this case, we say that the answers will never be negative. So we say the range is anything from 0 all the way to positive infinity. Notice again the use of the bracket because it does include 0. Yes?
I thought when you take the square root of things, though, you get plus or minus. So
I'm thinking.
it's like if you take the square root of 25, it's plus or minus 5.
Okay, that's an excellent question. When you graph, in fact, do this right now. Go to y equals on your calculator and type in the square root of x. And when you type in the square root of x, you technically get an answer. You're going to get a graph that looks like this.
Yep.
Agreed?
Yep.
You get a graph that looks like this. So according to this graph, your range would be anything from 0, and it's only going up. It's never down here. So in order to get your range to be negative numbers as well, you would need to, when you type this in, you would need to type in the square root of x, and then you would also need to type in the negative square root of x. If you were to go to y2 on your calculator and type in the negative square root of x, you're going to get a graph down here. So then your range would be anything. So Melissa, I'm talking myself through this right now. I think that if this function had said positive or negative square root of x, then you would do both. Then it would be negative infinity to positive infinity. But because the positive and negative were not included there, we're only talking about the positive values. Okay, but that's an excellent question.